So I'm sure you guys are all wondering what's coming up in the course, what coding is in fact, and how we're going to be creating our first Scratch project as well. So to help me out, because I've got loads of stuff to cover today guys, I also have my little friend Ty here, and he's going to be your guide. So if you have any questions, you can talk to me, my name is Tig, or you can talk to Ty, which is my little friendly aide. So now let's begin with Scratch for Beginners. What are we going to be looking at? Well, the lesson layout works like this. We are going to have 30-minute lessons, and that is just the amount of time we have to cover all of the content for that day. Then we'll start by doing our bonus Q&A session at the end, where we can discuss everything that we've just learned. If you have any questions for me, or if I have any questions for you guys, we can talk about it. So we're going to maybe go a little bit over 30 minutes in each lesson, but don't worry too much about it. Then we have the final assignment at the end of the course, which will be after lesson 8. We'll be posting up the final assignment, which if you're only a temporary member does have a €5 fee. However, it will be okay. We'll get talking about it at the end of the course in more detail. For the moment, I'm sure you guys are all really just wondering, what are we going to be making? Am I right? Everybody type into the chat box now if you think you want to learn what's next. Or maybe you just don't care and you're looking out the window at a nice, lovely, sunny day wishing it was no. Everybody seems to be typing in yes, and what are we doing? So let's have a look. Well, in week 1, which is this lesson and the lesson we'll have in 2 days' time, is our introduction. So we'll be looking at creating a game character and talking about some of our favorite games and learning how to move sprites across the screen. And then we'll be looking at making the very first game that was ever really made, which is Pong. I will be looking to make all these kind of things. We'll also be looking at all the different types of projects that you can use and learn in Scratch, such as art and music projects as well. So for maybe an art project, we're going to try to make like a pattern generator, something to just make really cool wallpapers and stuff like that. And then we'll be doing our music challenge as well, where we have, does Aliens have talent? Or maybe we'll do, does Scratch have talent? And we'll have a look at making our own concert. Then we'll have our maths and our stories week, which is going to be making a quiz where we test to see how much maths we can do in Scratch, and having a conversation with a fish who lives under the sea as well. So we have loads of things to do. And of course, let's not forget about games. In the last week, what I'm going to do is I'm going to do a 2-part lesson where we learn how to make a platformer. So that'll be a game where we can run and jump and shoot enemies as well. So loads to cover in this course, and so I'm afraid, Stephen, we won't have time to do all of this today, but we will start with the first week, which is the introduction. So now let's have a look, just briefly beginning, at what is a computer. Do you guys have an idea of what a computer is? Type it into the chat box if you do, because it's always very interesting to find out how much people know about computers before we begin. Okay, so it seems like everybody has a good idea. They all seem to know what it is, and Ayasha, I hope I'm saying your name right, says the computers are a machine. And that's exactly what a computer is. It's a machine which follows instructions to work things out. And we can find machines everywhere we look. So we can find them in our laptops, our mobile devices. We can find them in some of our favorite consoles as well. It's even in some of our favorite toys. I don't know if anybody's had a chance to play with the new Mechanoid toy that was out there at Christmas. It's unbelievable, so it is. I had a chance to build one myself and then program it as well. Lots of fun with that one. Did you know that there's computers even in your favorite remote control cars, or maybe your kettle even? There is a small tiny computer chip that sends a signal to the remote control car, and it tells it to go forward or turn left or turn right. And it's the same with the kettle as well. If you want hot water, you need to press a button that says, okay, boil the water now. And all of these things, guys, they're all considered hardware, as Ty has just reminded me there, because in real life you can touch them. They're real things that you can hold, and they're considered hardware. So if you're ever confused if somebody asks you what hardware is, now you can tell them. Olivia's saying it's like armor. It protects it. So let's have a look now if you guys know what coding is. So just type in if you understand, or maybe you have an idea of what coding is. Let me see. I'll have a look at some of the questions that are coming in. If you're having trouble with the chat box on your iPads or anything like that, guys, there should be a question mark on the screen which you can click onto and type into using that. It's a set of steps that tells the computer what to do from Athir. It's the language of a computer from Yusuf. And Claire is saying it's programming for the computer. Well, yep, programming machines is exactly what coding is. It's writing the instructions for the computer. So you're basically, when you learn to code, you're telling the computer what to do. And a finished set of instructions is called a program or an app. So let's have a look at when we were starting out with computers. Somebody said, I want to be able to watch all of my favorite TV shows whenever I want by clicking onto an app. And then we had Netflix. And of course, everybody loves Netflix. Somebody then said, I want music. I want all of my music. And we got Spotify. And then, of course, somebody decided that Spotify and Netflix wasn't enough, that we also need to be able to tell people all about the things we're doing every day. And we had social media like Twitter and Facebook and all the other ones as well. But of course, we didn't just stop there. That was just the app side of it. Then we got creative and we thought, let's make games as well. So then we had Slither.io. We decided then that even Slither.io was too complex. We wanted games where we could just build blocks all day long. And we got Minecraft as well. And of course, then people said, well, I want to play games that are based off some of my favorite films. And we have games like Ratchet and Clank as well that are now coming out onto the consoles as well. And guys, all of these things are considered software because they're programs, because they're apps, they're things that you can't physically touch in the real world. You might be able to click on the app, but you can't hold Netflix, you can't hold Ratchet and Clank because they're software. So let's have a look now at coding computers, which is what this course is really all about. So computers are brilliant. They don't get bored, they don't forget how to do things, they don't muddle things up. And they can do really complicated tasks really quickly. However, computers will do exactly what you tell them to. Because computers are dumb. They don't think about what they're doing. Now, if you tell a computer to go to Netflix, it will just go to Netflix. It doesn't care if it's morally right or wrong to go to Netflix. If you've just watched 7 hours of Netflix and the computer thinks that you should take a break, it'll still go to Netflix and let you watch more and more and more. If there's a bug on a computer, there can be an error in the code and they can fail. Like from time to time when the Show Academy website crashes, sometimes we need to restart the website and get it up and running again. Or maybe it's something as simple as a self-destruct button on your favorite bit of a game and everything blows up. So let's see. Let's see some of the questions that are coming in. So why did TV say that they will turn off? That's a great question, James. Why do TVs tell you that they'll turn off? Because you've been watching them for 4 hours or more, and you're maybe not watching TV, you're playing games, and the TV's actually got a program built into it to say, well, this TV hasn't been watching TV for 4 hours, but it's left on, so it's just wasting electricity. And that's why it'll ask you, do you want to turn off the TV? And guys, if you're wondering why your answers aren't coming in on the chat, it's because it's just myself here today. I am talking at the moment. I'm going to be answering as many of your questions as I can, so do listen out for them. I unfortunately cannot type in to answer your questions as I'm teaching, so don't worry about it. I'll get round to answering all of your questions at the end of the lesson. Let's have a look at some of the maths that computers can do. For instance, let's have a look at this question here. We have 24 multiplied by 60 plus 30. Guys, well, let's just do a quick poll, just in case some of you guys are wondering what all this is. So let's have a look. I'm going to put the poll up onto your page now. And hopefully everybody can see it. There's two answers here. We have 1470 or 2160. Which do you think the answer is? I'll give you 3 seconds because a computer will have already got the answer. So I'll give you 1, 2, and 3. Now I'm going to close the poll now. Just 1 more second, just in case there's a few more answers. Okay, so it looks like 56% of you guys said that the answer was 1470 and the other 44 said 2160. Unfortunately, you're both right, but the computer is always going to tell you it's going to be 1470. Now the reason for that is because when you tell a computer to do the maths, it just does it from left to right. So when you tell it to do the addition first, you have to use BIDMAS, as Stephen is saying, so that we have to add the numbers together first and then multiply by 24. Otherwise, it's going to multiply 24 by 60 and then add 30 from left to right. And that's how computers work. If we want to do this part of the sum first, we have to do it and then tell it to multiply with 24. So now let's see if you guys will get the next one. And I'm hoping everybody can now see the poll up onto their screen. It's again the same question. We've just changed the question a little bit to say what happens when we add 60 and 30 together first. And amazingly, everybody is answering 2160. So it seems like we all have a pretty good idea of what the answer is going to be for this one. And I'm going to just close my poll here. Well done for everybody. You seem to have it all wrapped up. It is in fact 2160. And that's what I talk about that's what I mean when I talk about a computer needs to know exactly what you mean when you code it. So that will just take a quick moment now. We'll answer some of the key points that we've just learned, and we'll look at some of the questions that are coming in. So machines that follow a set of instructions to work things out. What are they called again? Can anybody type into the chat box now what they are? That's right, they're computers. So everybody seems to understand that they're computers. And computers simply are a machine that follows a set of instructions to work things out. They can be calculators as well, and of course PCs, and lots of different types of answers coming in. What about writing instructions for the computer? What do we call that? And we're loads of answers coming in. Code, coding, programming, HTML, lots of different answers for it, and that's all exactly right. And finally, why do we need to code exactly what we want the computer to do? Maybe you don't know, maybe you do. You can type it into the chat box now. Because computers are dumb. Yeah, that's because they follow exactly what they're doing. They don't question about it. They just answer the question and then go, what do you mean it's not the right answer? This is what you told me to do. Alrighty, so everybody seems to know exactly where we are. Which means we don't have to do any more theory on this subject. We can just start going into Scratch. So guys, after today's lesson, I want you all to go to scratch.mit.edu and you'll see the Scratch website. I want you guys to start creating an account, or if you have an account already, you can sign in. If you're looking to create an account, you can click on the button here in the top corner called Join Scratch, and then you'll be able to create your projects, and I'll be able to see your projects, and I'll be able to give you feedback on each of your projects as well. So let's have a look at the Scratch website and have a bit of fun with it for a moment. Here you can see if you want to create your own project after you've signed in, you can click on the Create button here. Here's a project that I have made already. If we click on the C inside, I'll just get rid of this code here now so we can start again. And what we have here is our layout. So first of all, the first thing I'm going to show you is this part here is our stage. And that's where we're going to see everything that happens. We also have a thing called sprites, and we'll get into them in a few moments, so don't worry too much about it. If we click here, we now have our backdrop, which is a thumbnail for our stage, and we can change the backdrop by painting. One of the cool things about Scratch is that the stage is actually divided up into 4 sections. So in the very center of the stage, we have 0. I'm hoping my drawing skills are coming up okay on the screen. So we have 0, 0 right here in the middle of the stage. And if we go over to the top corner, we'll have something like 100, 100. We'll have minus 100, 100, minus 100, minus 100, and 100, or minus 100 and 100. We'll get more into them in a few moments, or maybe even in the next lesson. For today's lesson, I just want to familiarize everybody with the lesson or the layout of Scratch. And if you want to create a new backdrop, you can just paint a new backdrop there. Or you can even select your own background as well. So maybe we'll go with something funky looking as well. What about our Grand Canyon? And we can see that the background has changed completely. So if we click back onto our sprite, we can check out the Scripts tab. And here we can see the block palette.